I will hand over the microphone to Leo, who's going to tell us what questions you've been asking yourselves as I've been speaking. Leo, up to you.
Okay, Philip. So I have a lot of questions, and one of them was, what are your ways to really identify the bottleneck?
Yes, obviously, if you can't identify the bottleneck or hesitate about how to identify the bottleneck, you can't do the theory of constraints, right? So it is critical, and especially one's first time, one doesn't want to get it wrong, and therefore one hesitates, and one has all sorts of thoughts and stuff. The simple way of doing it is, one, forget what your computer system says, forget what your ERP says, because necessarily all bottlenecks have been hidden in the computer system. Why? Because every year you do annual budgets, and all the middle management is therefore required to show that it has just enough capacity, not too much, not too little, and so it will dissimulate all the discrepancies in capacities, right? So if you look at your ERP, it will not give you the truth about where your bottlenecks are. It'll be that much worse because, in fact, we're now finding a lot of our bottlenecks are not in traditional parts of the process, where there are time per parts and capacity calculation. Take quality control. Quality control is very rarely modeled as a capacity and a resource. You don't want to put pressure on quality control, right? So it's not in the model, and you won't even see it. So don't look at your computer system; it doesn't know. What we do is just Gemba. We walk down the flow, and we're looking for queues, and normally the queue will be about 1/4, if not more, of the overall lead time, and that will mean that you found the bottleneck, right? That's why we've got our company logo, right? Is the all those tanks feeding one another. That's just physics, right? The stuff is going to pile up in front of the bottleneck. That's what you need to find. Okay, so that's how we do it. I know often people are asking themselves, since they're also using lean, would a VSM help? And it might or it might not, because you want to find the capacity bottleneck of the whole of your portfolio of products, right? And if you choose the product in which you do a VSM wrong, it might not necessarily give you the right indication of where the bottleneck is. Okay. And so that's how you do it. The first thing that's easier for me than for people who are starting, of course, is to know that it's there somewhere, and just keep hunting and hunting and thinking until you find it, right? It is there somewhere necessarily. And also, once you've found it, it's quite easy to check whether it makes sense. That's to say, if it had a bad 2 weeks of production, did that have an impact on overall sales? Yes or no, whatever. There's a correlation between the performance of the constraint and the performance of the company, right? Well, there should be, and that should enable you to confirm your hypothesis. Okay, and also, frankly, if you want to start, if you're starting your theory of constraints journey, have the courage to get it wrong. It's not going to kill you if you get the wrong bottleneck. You'll quickly find out, because something else in the factory won't keep up with what you thought the bottleneck was. Okay. And just one final word of warning. So often people think that their bottlenecks wander around from place to place according to the product mix, according to this, according to that. They very rarely do, right? Certainly none of the cases we've seen to date was the bottleneck moving around. It's just people panicking and going from one place to another and creating big waves of work with huge batches, that sort of stuff. But there are structural bottlenecks that are there hidden behind the waves of work. Those are the ones you want to find.
Next question, Philip.
Yeah.
It was, how difficult was it to convince management to stop local performance indicators and focus on global performance? For example, in the world leader fast food case.
Yes, good one. The world leader fast food, we started implementation in France, 1,500 restaurants, a big organization, but only France, right? There was a reporting KPI, which was the speed measured in seconds between the moment client orders and the moment it's started on the toasters in the kitchen, right? How quickly the kitchen started a client order. That is a traditional indicator that's been hanging around that company for decades, if not right back to when it was born 50 years ago. And so in I go and I say, you have to get rid of this. We managed. It was turned off and taken and taken out of the computer systems for the French organization. We haven't yet got to it being an international decision, global and stuff. So it's for the moment a partial success. That's with regards to the corporate and official KPIs and stuff. The battle to convince people within a restaurant to do it was much easier because there was a huge difference between the quality of life before and after in what we did. Before they were just running around like chickens with their heads chopped off, looking around for their lost hamburger, screaming and asking for another one, stealing hamburgers from one order to another and stuff. And when we managed the flow as we did, everything just sort of calmed down and became sensible and right first time and all that stuff. And they could understand why it was unnecessary and not very intelligent to pounce on a new order if in fact you hadn't finished another order. Better to finish that order, deliver that client, and then turn around and address the next one, right? But that's a very good question because it's counterintuitive that often to finish faster you must start later. That's been in many of the examples we've seen today, right? To finish earlier, you must start later. That's a message that needs to be hammered through time and time again. It's not maybe common sense.
I had a lot of questions regarding the differences between TOC and Lean.
Yeah.
So I'll take one among them. If properly applied, wouldn't Lean have allowed companies to increase throughput?
It's always frustrating when I have to do this sort of 1 hour stuff. Yes, of course. I encourage people who are interested more about this, the dilemma or the conflict or the complementarity between theory of constraints and Lean, to have a look at one of my videos about TLS, and it's based on identifying good and bad Lean, good and bad TOC, and good and bad Six Sigma. And to my mind, by looking at those different components, you understand why everybody is in fact right, and there's no reason to be fighting much. So the question is, doesn't Lean go for increase in throughput? And I think good Lean does and bad Lean doesn't. And it's strange really, because as I say, I've been following what Toyota's been doing for nearly its thing, its Toyota production system, Toyota management system, Toyota way, whatever you want to call it. Okay, and it has always been doing this to become the largest car manufacturer in the world, right? It started in a tiny facility after the Second World War, and now it's huge, right? So it has always had a quest for more volumes and greater sales and stuff. And it means also, by the way, that it had, in this good Lean system, it meant that the increase in sales were always sufficient to be able to absorb the increases in productivity, and therefore it could avoid reducing headcounts. So you could go on doing savings here and there, but the savings wouldn't be transformed into reduction in headcounts because sales had grown, so the person could go to another job doing something else in the factory. Okay, so yes, to my mind, clearly, good Lean is exactly like the theory of constraints, and it is what I would call the throughput world, looking to increase sales. It's also the world of entrepreneurs, right? Entrepreneurs are more in terms of how they can double their sales and grow the company rather than shrink it and cost cut it to death. So yes, I completely agree with that comment that Lean can be a search for throughput. Unfortunately, to my mind, most people are practicing bad Lean, and in fact they're just spending all their time cost cutting, no time at all increasing sales, and as a result it's a process of downsizing, using Japanese words, slowly destroying the company. And that's bad Lean, and it's the majority of what's going on in what I call the ex-first world, right? Countries like France, Germany, England, America, all the old rich nations, right? They're implementing bad lean, and it's just a way of chopping little bits off every year and getting smaller and smaller.
Next question. Is it possible to apply theory of constraints and critical chain project management on some part of the business only, or should they be applied to 100% of the business operations projects to be efficient?
It gets messy if you try to do parts, but let's talk about part. You can certainly apply a production model to any separate unit, right? So a factory, of course, within a company. If your factory is broken up into mini factories, channels, or whatever, you could apply it just to one channel. The third case was like that. They had 6 channels, 6 mini factories in a factory, and you started on one of them, and you could perfectly do that. So it's not that difficult in the production drum buffer rope flow control arena. Critical chain is kind of different, because you're going to have trouble if you try and run a portfolio where not all the projects are run in the critical chain way, simply because critical chain changes all the basic vocabulary, in particular stuff like the duration of a task and the end date of a task. It does not mean the same thing at all in the traditional world and in the critical chain world. So if in a portfolio you've got some critical chain projects and some non-critical chain projects, you just will not be able to compare them, and you will not be able to arbitrate the priorities and the statuses of those that are under critical chain and those that are not. Okay, so in the case critical chain for a given portfolio, they have to be as quickly as possible all under critical chain. You won't be able to have part in, part out, otherwise you'll have a tower babble. It will be a mess. Okay, but companies can have several portfolios that are separate with resources that are working on them and so forth, and then you could have a portfolio with critical chain and a portfolio without critical chain, of course. I hope that's answered the question.
We have a question from probably a TOC beginner, because what are the steps to implement TOC? Is there any specific process?
Yes, let me see. You're going to get all the slides, right? So you'll be able to. It's there, but tiny, and it's on our website and YouTube channel and all that stuff. It's here, up on the top right hand corner of the slide. The 5 focusing steps of the theory of constraints. Okay, that's the process. And if you look on our YouTube channel, there's a 5-minute summary of that that I give. It's one of our most watched videos. I'll run it through very quickly. First, you identify the constraint. We talked about this a lot during today's webinar. You decide how to exploit it. That is what you can do immediately without spending any time or money. What can I do right now to get it to produce more? And normally we find you can get between 20 and 100% more out of that machine simply by focusing on that particular resource and not wasting time on everything else. Subordinate is to make sure that you don't put into the system more than the constraint can handle. And we've seen a lot of that today. Elevate is once you've done the previous steps, you can then start spending money, taking time to go even further and improve the performance of the constraint even further. And if you do that little by little, the performance of the bottleneck will get so much improved that the bottleneck will go elsewhere. Hence the step 5. It's moved. Go back to step 1. Start again.
Philip, can you explain more about fever chart? We have this kind of question. Also, some people asking, how do you define the yellow, green, and red?
Okay. So here's a fever chart. I think you can all see my mouse. Have a look at the videos on critical chain. It's a strange, weird ovni, right? And normally everybody falls in love with it pretty quickly. This fever chart, right? On the horizontal axis, it's the beginning of the project to the end of the project, right? And on the vertical axis, it is the buffer consumed, right? From no buffer consumption to full buffer consumption. In critical chain, I haven't got the time for the details, about 1/3 of the duration of a project is buffer, right? So if you have 6-month project, you might add 2 months of buffer at the end, right? Which belongs to everybody, you're allowed to consume. Anyway, and so you start projects down here, and your projects get executed like this. If they go at the speed expected, you're going down here. If they have problems, they go up, right? And you're meant to finish off up here. If you finish off up here, you'll finish just on time, okay? The colors are completely empirical, arbitrary. Those are the colors and the shapes that we would normally recommend from Marris Consulting. Green starting up here, and yellow and red. Why is that? Because in this part there's a bit of noise, and you don't want to get upset if things get strange right at the beginning. So yellow is a bit above, and at the other extreme, red does cover the area on the vertical axis. It's trying to force people to finish their projects early, for a simple reason that none of us ever forget when we're taking a plane, right? If you want to catch a plane, if your project is to catch a plane, you don't want to miss that plane. What do? Well, you plan to get to the boarding gate a certain time before the plane will depart, right? You plan to finish your project early. The only way of finishing all your projects on time in an uncertain environment such as projects is to plan to finish them all early, hence the red in this part up here. Okay, and those colors, what do they mean? Green, it means that you're basically in the noise, you're in normal variability. Yellow, watch out, variability is getting high. Red, something special's gone, happened. Have a look, you need to react, you can't go on like that, otherwise your project will be late. Okay, but have a look. There are 4 videos of 20 minutes that take you through all that stuff with a lot more detail on the Marris Consulting channel, right? There's a 5-minute version and a 1-hour version.
Philip, is it true that TOC is practically used for production rather than project management?
No, I would say today, in 2020, the market share of theory of constraints is probably larger in critical chain than it is in production these days, because people have considered that the way to run manufacturing is lean. That's the way to do it, and so that's got a 99% market share, or over 90 anyway. And as a result, even though the goal, many people have read the goal and all that stuff, the production implementations of theory of constraints are not that frequent. So I'm considered today, it's changed over the past 10 years, but today there are more going on in critical chain. But when I say it that way, it's because often that people are applying the ideas of the theory of constraints within a lean program and not calling it theory of constraints, right? In that Mexican desert implementation, we did this, we implemented it and stuff, and I still remember one of the 11 plant managers, right? There was a mad situation. The local guy, when we'd done all this and got all these fantastic results, he called me into his office and looked around and made sure nobody was listening. And he reached down into his drawer, bottom drawer, and pulled out a copy of the goal. He said, "I love the goal, but I can't say so." And he hid it away. Anyway, that's production. In critical chain is gaining fast market share. For those that don't know, it's the Project Management Institute, the main authority in project management in the world today, with 1 million members throughout the world. Awarded the prize of the best project of the year 2019 to Embraer for its development of the E90-E2 aeroplane, which broke all the records, finishing early and so forth, and was developed using critical chain. Okay, and so things are starting to move significantly. I'm now regularly in contact with all kinds of PMI organizations and chapters throughout the world and in Europe. And there's a lot of interest in critical chain, and a lot of implementations going on of critical chain. Okay, now the fact that Microsoft project doesn't have critical chain, okay, that's an issue, but it doesn't actually prevent people from quickly switching to critical chain, because you can continue using Microsoft project and tweak it so it does critical chain and stuff like that. So it's not really a tool issue as such. It's not the software that will block or not companies wish to switch to critical chain. No, it's just a strange new way of doing things, and therefore people are hesitant to do it, even though the results are extraordinary. The results of critical chain are basically you do your projects twice as fast and you do twice as many of them a year and you finish them all on time or nearly all on time. And people think that's impossible. And so watch out, I'm a horrible consultant, I must be lying. Have a look at all the videos by our clients.
Could the detection of the bottleneck be based on employee interview, or does it require us to go and observe by ourselves?
It depends really. It depends on the company. When I took employee interview, middle management is not too good at identifying where its bottleneck really is, but shop floor workers are, and clearly when I have a suspicion of a bottleneck, the first thing I'll do is I'll go and talk to the workers and the foreman and whatever and say, what do you think? Is this machine the bottleneck? Could it be the bottleneck? And they will know, because any good local manager of a production unit already has the theory of constraints as an obvious common sense, right? When he goes away for the weekend or whatever and they're running overtime and stuff, he'll tell the team that's producing, if machine 22 breaks down, call me immediately, right? He already knows it's critical and it's more important than everybody else. So usually on the shop floor, people already have this logic and this way of thinking of the critical chain. They have to fake work, right? When you're a non-bottleneck, you don't have enough work for your shift, so you have to slow down. There's no other way to do it, and you only work when the boss comes. So on the shop floor, people already know all about the unbalanced plant, and so that yes, you should ask them their opinion on where the bottleneck is. And middle management has more trouble simply because they're paid to get rid of bottlenecks, and therefore they would be admitting a failure if they said this is a bottleneck, because their boss would say, well, why didn't you do something about that in last year's budget, right? At the end of a budget, all the middle management of a company signs a piece of paper saying there are no bottlenecks, and therefore they can't say there's a bottleneck 2 weeks later. They're paid to avoid bottlenecks, and so they're rather constipated when talking about where the bottlenecks are. Yes. Well, that's why it's a 2-for-1 rule rather than stop. I mean, why that 2-for-1 rule came because some people have suggested that you should freeze if you have too much work in progress in a factory. You should freeze and stop all launches and just finish the stuff that's in there and quickly empty the factory. For a number of reasons, I think that's dangerous and not the right way to do it. So this is halfway there, right? Twice as much must go out than what's coming in. And so the workload on the resources working on the initial operations will be reduced by 50%. What do you do? Ideally, you move them, and you move them downstream to the last operations. Okay, and if you can do that, in fact, you will increase the number of people working on the last operations, and you will increase the throughput, and therefore there will be more coming out every day, every week, and whatever. And so, in many ways, you'll convert that rule into twice as much coming out, and the same quantity going in. So you're selling twice as much, and yet you're applying 2-for-1 rule. This we do it a lot. Sometimes people are so specialized that they consider it's not possible. Let me give you an example. We did this with the ball bearing. Well, we do it all the time, 3/4 of the time. Ball bearing manufacturing, right? We had these beautiful milling machines, very expensive and stuff, and we applied the 2-for-1 rule, and these very expensive machines ended up with 50% load. And what would we do? Well, we got the employees that were running these machines to go down to quality control at the end of the factory, where in a very contained environment, very clean environment, there was a visual inspection of the ball bearings. These are aeronautical high-end €20,000 shot ball bearings that had to be visually inspected for scratches and stuff. And so we got all the workers that usually ran the milling machines to go and do some visual inspections for a few weeks, and that was great fun. It meant often it was the husband and the wife, right? The husband was on the milling machine, the wife was in the quality control. Anyway, they had great fun, and it led to great discussions about how they could avoid scratches and stuff in the future, and the quality of the products improved. So we controlled twice as much coming out, we improved the attitude to quality, and we broke some silos between quality and production all at the same time. So pounce on that reduced workload to change things and do some fun stuff. That's what we do. The 2-for-1 rule is only a transition, right? You'll have to run the 2-for-1 rule. It depends a bit on how much inventory you have when you started, but it's just a transition phase, right? It's not a new way of doing things. It's a transition to get you to where you want to go to be.
How much does culture play in the problems you identify, and how would you go about changing a culture?
Well, I guess culture is about 197% of what we do. Our job is to change individual and collective behavior. That's our job. So the theory, the mechanics, it's just very easy, right? You just buy the book, right? You just buy these and implement and then do it. So our work is all about change management. I don't talk about it much because I don't think people are interested in what I might have to say about it. What we do, why we don't have a problem, as you can see, from whatever the environment, from French railways to very, very different environments. We have to adapt the approach to that environment, to the culture of the company, to the country in which it is in, and all these things. And basically, we just build a win-win solution. Very ambitious, and we do some what I call bad consulting initially. That's to say, we ensure that they get those first results, those extraordinary, strange, unbelievable results, because consultants don't have a reputation for not bringing results, right? So a lot of the work when we start, it's here's another consultant this is going to waste our money and get no results. So we have to break that idea, and we do that by getting extraordinary results very quickly. And that means we're a little bit too active in implementing solutions in the first days and weeks. And as quickly as possible, we then stand back more into a coaching role and get them to do it, and off we go. And it's a complex question, and that's a brief answer. I hope it'll suffice.
One last question: which prerequisites do your consultants require to be met for starting a remote diagnosis for R&D department doing product development?
What do they need to do? What the prerequisites are? We can pick up quite a lot of, before we actually start the diagnostic. We try and pick up a certain amount of data. So we need to get information about the portfolio. It depends on the maturity of the organization. Let's assume here they're sort of average. They already have some software and have modeled their developments, for instance, with Microsoft Project or whatever. So we get a copy of those files and have a look at what it looks like. Have a look at some of the key performance indicators, and those are the prerequisites in terms of information. There's a significant prerequisite in managerial terms is that the company must want to implement critical chain, obviously, because convincing them of the beauty and power of critical chain is easier to do face to face, I find, rather than over the internet. And so there has to be managerial alignment to want to implement critical chain. Our way of doing this, which works very well, more or less 100% hit rate, is to train the entire management committee briefly. It can be a 2-hour thing, a 4-hour thing, whatever, to explain what critical chain is, because it's not complicated, and convince them by explaining how it works, a few examples, and therefore once everybody's got excited about, yes, I want to do critical chain and get those results, then comes the more mechanical part of applying it to the portfolio. But there's no big complexity involved in critical chain. It really is, many people say, just common sense. The most difficult part of implementing online critical chain is not in the diagnostic. It is the moment when you have to apply the rules of critical chain to project durations. Critical chain, I haven't got the time to explain all the details, basically says you can cut on average the durations of your tasks by a factor of 2, maybe 3. Okay, I used to say that to design this thing it took me 100 hours. Okay, well, with critical chain we have to get that same person who's doing that job to say, I think I can design this thing in 30 hours. Okay, that's the difficult thing to get through online, or more difficult when it's online rather than face to face. We get it done. You have to explain. That's why for those people we take a whole day of training, or 4 times 2 hours of training. It's not the same question. We're not asking for a commitment to finish in 100 hours. We're asking them their time on average in the best conditions with full kit. Do you think you can do? Maybe on average I can do it in 30 hours if I have everything in, if I had no problems. That's the difference in the question. But it takes more explanation and repetition to the various people who are going to be giving those times. That's the challenge in critical chain, is that key moment when people admit that, I've been here for 10 years and I've always said it took me 100 hours, and all of a sudden I'm claiming I can do it in 30. That's the key point. Always has been in critical chain the key point, and it's more difficult online than face to face. That's it. Thank you very much. As I say, the idea of these webinars is that as many of you as possible can carry on and just go out and do it. That's why I put the case of clients that have just done, either a book or training session, and that was enough. This isn't complicated. None of it is complicated. It's more a question of courage, audacity, than complexity. So I hope many of you will go out and try it if you haven't tried it, or if you've only been doing it in production, try the project side, or if you've only done it in projects, try the production side, or throughput accounting, whatever. Anyway, these webinars are here to try and get you convinced that you must start doing it, and we'll be giving more webinars such as these to help you on that journey. And as I said, we've got training sessions if you feel you need to get more information. And there are all those good books. I mean, watch out. The main difference between you guys and me is I've read the books, right? And then I tell you what's in those books at €1,000 a page. So you just decide what you want to do. But I'd recommend you read some of those books. The only advantage I have over you is I've read them. Okay. Anyway, that's it from me. Have a nice day, and just go and do it. Bye-bye.